Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve these two problems based on the concepts of vectors in R3. So let's start with the first problem. So the vertices of quadrilateral ABCD are given as A, B, C and D. Prove that ABCD is a parallelogram. So the first step is to draw a quadrilateral ABCD. So let's assume this is our quadrilateral ABCD. Now this quadrilateral is a parallelogram if its opposite sides are equal in length and have the same slope. So in vector world, that means that the vectors that represent the opposite sides of the parallelogram should be equal to each other. So that means vector AB should be equal to vector DC and vector AD should be equal to vector BC. So if we prove that these two pairs of vectors are equal to each other, then that means that ABCD is a parallelogram. So let's start with the left pair. So vector AB is equal to vector DC. So we'll have to find vectors AB and DC based on the given information. So let's start with vector AB. So we should break up vector AB into its position vectors, and that will be OB and OA. Now these position vectors OB and OA are equal to the given coordinates for points B and A. So vector OB is equal to, and vector OA is equal to. Now we can subtract these two vectors. So we have to subtract the x, y and z components of these two vectors. So for x we'll do 3 minus 0, which is equal to 3. For y we should do negative 1 minus 3, which is equal to negative 4. And for z we'll do 17 minus 5, which is equal to 12. So this is vector AB. Now we can find vector DC. So we'll break up vector DC into its position vectors. So vector OC is equal to the given point C, and vector OD is equal to the given point D. Now we can subtract these vectors. So we'll do 7 minus 4, which is equal to 3. Negative 3 minus 1, which is equal to negative 4. And then 15 minus 3, which is equal to 12. So this proves that vector AB is equal to vector DC. Now we have to prove that the other pair of vectors are equal to each other. So let's start with vector AD. So we'll break up vector AD into its position vectors. So vector OD is equal to the given point D, and vector OA is equal to the given point A. Now we can subtract these vectors. So we'll start with the x components. 4 minus 0 is equal to 4. 1 minus 3 is equal to negative 2. And 3 minus 5 is equal to negative 2. So this is vector AD. Now we can find vector BC. So we'll break it up into its position vectors. So vector OC is equal to the given point C, and vector OB is equal to the given point B. Now we can subtract the vectors. So 7 minus 3 is equal to 4. Negative 3 minus negative 1 is equivalent to negative 3 plus 1, which is equal to negative 2. And 15 minus 17 is equal to negative 2. So that means vector AD is equal to vector BC. So that proves that ABCD is a parallelogram because the opposite sides represent vectors which are equal to each other. So we are done with the first problem. Now we can analyze the second problem. Given 2 times vector x plus vector y minus 2 times vector z equals 0 vector, and vector x is equal to negative 1 comma b comma c, and vector y is equal to a comma negative 2 comma c, and vector z equals negative a comma 6 comma c, determine the value of the unknowns. So in this problem, the unknowns are a, b, and c. So we have to find their value. So for that, we'll use the given vector equation. So the first step is to sub in the given vectors x, y, and z in this vector equation. Now we have to do the scalar multiplication. So we'll multiply the first vector by the scalar 2. So we'll multiply each component in the vector by 2. So the middle vector will stay the same. Now in the third vector, we'll do scalar multiplication. We'll multiply each component in the vector by 2. Now we can combine these three vectors. So we'll start by adding the first two vectors. So we'll add their x, y, and z components. So the x components are negative 2 and a. So we add them and get negative 2 plus a. Now we can add their y components. So 2b plus negative 2. And now we can add their z components. So 2c plus c is equal to 3c. Now we can subtract these two vectors on the left side. So for the x component, we'll do minus 2 plus a minus negative 2a, and minus negative 2a will become positive 2a. So we get minus 2 plus a plus 2a, which is equal to minus 2 plus 3a. So I can show you the step on the side. So this is how we get minus 2 plus 3a. Now we can combine the y components. So 2b minus 2 minus 12. Minus 2 minus 12 equal minus 14. And then we do for the z components 3c minus 2c, which is equal to c. So this vector on the left side equals the 0 vector. The 0 vector is a vector in which all three components x, y, and z are equal to 0. So we can use that to write an equation for the x components, another equation for the y components, and the third equation for the z component. So let's start with the x component. So on the left side of the equation, the vector has x component negative 2 plus 3a, and on the right side there is a 0 vector, and the x component in that 0 vector is 0. So that means negative 2 plus 3a is equal to 0. So this is our first equation. So the second equation can be for the y component. So in the vector on the left side, the y component is 2b minus 14. And in the 0 vector, the y component is 0. So this is our second equation. And now we can write an equation for the z component. And in the vector on the left side, the z component is c. And in the 0 vector, the z component is 0. So our equation is c equals 0. So this is the final answer for the value of c. Now we can solve for a and b. So we can start with our first equation. So we have to isolate a. So we should add 2 to both sides. The 2's on the left side get cancelled out. Now we can divide both sides by 3. So a is equal to 2 over 3. So this should be the final answer for value of a. Now we can solve for b. So we have to isolate b. So we should add 14 to both sides. Now we can divide both sides by 2. So I got b equals 7. So this should be the final answer for this second problem. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.